welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, and it's hacker o'clock, 8 o'clock, about 8:30 on a Sunday night. I've been working a lot actually this week because the weather got a little colder, so a little bit more indoors, working on some new designs and revisions, and I thought I would just get right into it and show you some of the board designs that I've been up to this week.
What are we doing? Where are we going?
Let's go to the computer. Let's go to the computer. Sorry. So first up, chip shortage is not over. Nothing ever ends. But there are more parts available. Oh, dude, I forgot to set this back to 720. Hold on.
Oh yeah.
Yeah. 1 second. I forgot that I had this set. Okay. I was wondering why is there so much space on my desktop? Okay, you should be able to see the text a little better now. Right, so some chips that are back in stock, not everything. So don't worry, the great search is continuing to find replacements for all the parts that have been end of life or discontinued or still unavailable. But there are some parts that are available. So the SI5351 clock generator, people really like this chip. It's really fun because over I2C, you can tell it to generate, I think, up to 160 megahertz signal. So ham radio people, RF people, but even just people who are I just need a clock of some freaky ass amount, you can use their calculator to generate basically any frequency from 8 kilohertz to 160 megahertz, which is great for reference clocks. Oh my goodness, there's so many boards. Hold on. This is the TPS. This is the... I gotta find it because I wanted to show you guys a bunch of things. Okay, so this is the design. Let me turn on the T-docu layer so you can see what's going on here. So I decided to QTify this design. I'm still going to sell the 3 SMA version, but I thought I'd make a small version. A lot of people only need one signal, or they're popping this into a dev board and maybe they don't need something as big as, I kind of wanted to find some alternative to just having one gigantic board with 3 SMA connectors. So this is a QT, and it's got the level shifting. I just picked a smaller crystal so it'll fit. Same chip, level shifting, and then what I did is this kind of funky design where there's this edge launch SMA, but they have 0.1 inch spacing. So what I ended up doing is having signal, ground, signal, ground, signal, and then only the signal number 1, the middle one, is SMA edge launch, because again, there's no mechanical space to have more than one edge launch RF connector, but I think that's okay, because I think, again, a lot of people need one signal, and if you need all 3, you pop in a breadboard, and then, of course, you get interspersed grounds, which is even better. So this is a prototype. You can see, the pads will be just really big here, but otherwise this will be a fun little stemma QTification. Okay, so the next up, let's go in order. We made the Metro Mini V2 a couple months ago, and it's in the store. Folks who remember, it's got the Atmega 328P, and then there's a stemma QT connector, and the stemma QT connector is 5 volt power and logic. And Adafruit stemma QT boards are 3 or 5 volt compatible, even on that SI 5351 you just saw. There's always a regulator and there's always a level shifter, and it's just kind of my thing. I don't like breakout unless there's some really good reason. I like my breakout boards to be level shifted and power protected, because there's still a lot of people using Arduino Unos. There's a lot of beginners who they accidentally put 9 volts into the power supply or whatever. Having a regulator and level shifter just protects you a little bit. Just it would be such a bummer to destroy, a $15 OLED because you accidentally put 5 volts into the 3 volt line. And I've absolutely seen that happen. So all of our breakout boards have level shifters, but if you're using quick boards or some other breakout boards that have that JST-SH connector, they may not have level shifting. They may be 3 volts only. So I made a little board that just, all it does is have the 5-volt regulator and level shifter, and there's no chip, so it's like normally there'd be a chip or sensor here, and it's just split in half where it's like 5 volts in, 3 volts out. So it's going to be like really inexpensive. It's only be a couple dollars, but if you want to breadboard with stemma QT connectors and have level shifting, this does everything for you. It's kind of like breadboard adapter / level shifter / floor polish / dessert topping. So a very simple little breakout board, but I thought would be, very handy. And you can see that nice silk screen because we now, of course, have the penguin script that we run on boards to make them very pretty before we get prototypes made. Next up, another QTification. I haven't run penguin on this one. The ADT 7410. This is a very nice precision temperature sensor from Analog Devices. This was one that we did as a partnership with DigiKey and ADI, but it's a very nice chip. It's like literally the last sensor we made before we started making everything stemma QTified. It was just like, you can see it's got like that same like shape and size, but it didn't quite make it to have the JSTSH connector. So we're going to revise this one as well because this chip is in stock. So when we sell through, we'll stock the stemma QT version. Just trying to get everything into the same format, same pin order, same connectors, just for cross compatibility, no soldering support. So that's the this is the ADT. So the only thing I had to drop is the address pins are now jumpers on the back. That's the trade-off when you go with stemma QTs. I really like to have those 4 mounting holes. I just think it makes it much more useful for people because you can like turn it into a wearable by sewing the 4 corners, or if you want to attach it into a case, you have many options for where to attach to. But I had to drop the address pins. But usually you don't use the address pins. Usually they're on the back and you solder them closed on the off chance that you need to change the address. So that's the ADT temperature sensor. Next, I'm going to go out of order. The PiCowbells, or Pico Bells, these, I got a little distracted for a bit. I know we designed these a few months ago, and I was like, no, I'm totally going to do these. And then, I ended up just getting totally distracted with a whole bunch of revisions and new products and stuff. So as a reminder, we can go to the overhead. I can show the previous version, because I did get the prototypes in. I wanted to start with making, boards for Raspberry Pi Pico. So I always start with a prototyping shield, because it's kind of like it's what I use then to design the rest of whatever I design. So with this, it just breaks out all the pins. You can barely see the text, but there's, there's label text. There's these white stripes are the ground pads, so because the ground pads are how you count the pins. And then we also soldered a little, this, I put this one together and I put it with stacking headers, and then there's a right angle reset button, because I figured that would be kind of nice to have at the end. But then as I was working on it, I was like, I really want to, especially when the Pico W came out, I think a lot of people want to add sensors very easily. And, if you're going to have this prototyping shield thing, it would be really cool if it also had a stemma QT connector. But there's not a lot of space on this. So what I ended up doing, you can go to the overhead. First up, I changed the computer. First off, I changed the through hole to a surface mount right angle switch, which meant me, I had a little bit more space for text here. And then I wanted to have the stemma QT. Now I couldn't have this and the button on the same side. There's just literally, you can't fit them next to each other without dropping some of those pads, and I don't want to drop the breakout pads. They're kind of the most useful part. So the stemma QT actually comes out the same side as the USB connector, which I think it's okay. It's a trade-off. I think, if you're going to plug in a cable, you're going to plug in USB, and then maybe you plug in the stemma QT, you have just cables coming out one end. On the other end, you have the button. I think it would be tougher if the button was if I swapped orientation, because then the button you'd have to reach under the USB cable. This is a stemma QT connector, and it's connected to ground and 3 volts because that's the logic level and power supply. And then, let me find the thing. So in the Pico core for Arduino, they do have a default setting for what the wire port is, and it's on GPIO 4 and 5. And so I actually just, I kind of just like said, okay, fine, I'll just connect these automatically to 4 and 5. So you see down here, GPIO 4 and 5 are pre-connected. I didn't add pull-up resistors because, again, all of our stemma QT boards, and all the quick boards as well, have pull-ups. Also, I just didn't want to add, I think it's kind of like, this is, people really complain I'm going to add pull-ups later, but I think for most people, they're using breakout boards with, pull-up, the pull-ups are built in, and they'll pull it up to 3.3 volts, and so I think that's fine. So this is the stemma QT port on this side, and then, the Fuchsial. So this is going to be a very easy breakout to make, and then, we've got a little grid of pads here. You could add other sensors or breakouts, or, you can't really fit a dip chip, but you can fit one anyways, because it's such a small amount of space in there. But maybe like resistors, capacitors, maybe like, 0.1 inch header. So, this cowbell is going to be the first one. And then I'll get to the others. I just was like, I couldn't quite get into this big project. All right, and then we're getting close to done. Okay, so then, this is a solderless stemma breakout board. I have a couple of these for some things like relays. It's like whenever there's a couple of things that people want to use together, and I've noticed that it's they want to use it solderless, I'll make something with one of these JST-PH connectors, like a big chunky connector. For example, let's see, I think I have like a stemma relay board. So like this board, for example, it's just a JST-PH and then a little bit of circuitry for, say, like running a relay. And I saw someone in the forums having an issue where they're like, well, I really want a very powerful infrared transmitter. And I was like, oh, yeah, like you really need like a MOSFET and, like a power transistor, and you need the LEDs, and you want more than one. And it's like, it's actually a little bit, it's not easy to wire up. There's just a couple of things that you need to do. And so I thought, oh, maybe I'll make a little breakout. Could also be useful for accessibility projects where it's like, okay, I want to make an IR blaster. And so this has, power, ground, and signal. You can use 3 or 5 volts. It goes into this N channel FET, which has a natural pull down, so it's, normally off. And then when you send the signal, it'll turn on and pulse these LEDs. And I sourced some LEDs that are like they're basically as powerful as the through-hole ones, but they're surface mount. One points up. So this is the vertical one, and this is the right angle one. So one points out, one points up. Because I was like, oh, people are going to want to have it, cover an area. And it's always like, do you want it pointing out or pointing up? And I was like, well, let's have one of each. Who cares? They're like, 10, 15 cents each. Each has its own resistor, and it's just powered by this transistor. So very simple. And then a little LED to let you know when the signal, because infrared is not human visible, this would have a little red indicator to let you know, okay, there was signal received. So this is simple little breakout just to solve that kind of problem, which I've seen a couple times. Okay, and then finally, I made a breakout for the TPS 61040, but also, maybe a different one. We'll talk about that in a minute. Once in a while when you're using OLEDs or LCDs, TFTs, or like there's sensors. Once in a while you need a bias voltage of like 12 volts. And it's not like you need a lot of current. Maybe you need like 50 milliamps, 100 milliamps, but you need like a little bit of current, or a little bit of current at a high voltage to like bias or enable some signal. If you're doing audio, sometimes like your audio amps, you need a 12 volt power rail. Even if your signal doesn't go up to 12 volts, you still need a lot of headroom. So we want to make a little boost converter breakout for this TPS 06140. This chip is a replacement for another boost converter that we really used to use a ton of, the FAN 5331. But as I was designing a FAN 5331 breakout, I realized that it's end of life, and so I had to find a replacement. So the TPS 61040 is the one I've picked, one of the ones I've picked so far, which leads us into the great search. But maybe there's some questions. No, let's just do it.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey Native. Thanks, DigiKey. This is the time of the week where Ladyada uses her power of engineering to help you find the things you want to find on digikey.com. What are you looking for this week, Ladyada?
Okay, so this week, chip shortage is not quite ending. It's relaxing a little bit, but there's still a lot of parts that didn't make it to the other side. And one of those is the FAN 5331. Now, you might be saying, Ladyada, you covered the FAN 5331 a couple of months ago. I remember that you found an alternative for it. No. My friend, that was the FAN 5333, which is the constant current version of this boost converter. I'm now going to be looking at the constant voltage output version of this boost converter. The boost converter before was what I used for LED backlights on 4, 7, 10-inch TFT displays. It's one, big LED chains where you want to have a constant current of 20 milliamps through multiple chains of LEDs. The FAN 5331 is what I use oftentimes for e-ink and OLED and TFT displays where I need a bias voltage, especially for OLEDs. This is very common. You need to give it a 9, 12, 16 volt bias to activate the OLED, even though it's not like the main power source. You do need 50 milliamps or so, maybe 20 to 50 milliamps available for all sorts of devices. As I just mentioned, sometimes audio circuitry also. You'll need plus 12 volts. Even if you're not using a full 12 volts for your audio signal, the rails need to be higher because you need a headroom for your audio amplifiers, and they go up to maybe 6 volts. So again, for biasing, this isn't a power, it's not what I would call a power boost converter. Although if you only need 100 milliamps, then it'll do the job as well. So let's go to the computer and let's look at this chip. So the FAN 5331, I really, really love this boost converter. 1.6 megahertz frequency, adjustable up to 20 volts, and it has a built-in 1 amp peak current switch, and it comes in a SOT 23.5. This thing is it was like bread and butter. Like I could toss into any circuit. It was, about $1 or less, and it did the job beautifully, perfectly, and they never blew up. They were super stable. Low shutdown current, low RDS on. Lovely, lovely chip. So you're like, wow, why don't you just buy more from DigiKey? That's a great question. If you were to find this part on DigiKey, you would see it is last time buy. Last time buy means they will do one more run, and then, if you need a couple of years worth, please put in the couple of years worth that you need to complete your manufacturing until you can change over to another part. I will do a last time buy because I like to have some backup for sometimes you find an alternative and the alternative isn't quite perfect. You might as well put in that last time buy order. However, I've also learned sometimes last time buy means no, that's it. We actually are never going to send it to you. I'm looking at you, STMP 811, whose last time buy lasted 2 years, and then I never actually got the part, and then they told me they will never send it to me. So it does happen. Not saying it's going to happen here, but I've learned when I see last time buy, I find an alternative immediately. So there are a couple alternatives suggested, but actually I wanted to, some of these might be okay, but let's use our patented searchability to find something similarness. So we want a DC-DC regulator with internal switches and one output. I'm not as picky about the internal, the min and max input voltages because, again, it can be wider, it can be narrower. Basically, as long as it's 3 to 5 volts. I'll try to find something with about 20 volts, 1 amp switch, and hopefully high frequency. I do want it in SOT 23.5. I want it ideally to be pin compatible and functionally compatible, so I don't have to redesign. Okay. So, and then, we're going to look at pricing at 1,000 pieces. So this is fun. This is the, this image is not correct. This is a SOT 23.5, but it's good to know. And there's a couple obsolete parts. Here's that fan 5331. So this is, last time buy. And then a couple others in that family. You can see the fan 5333 is also last time buy. So let's only look at active. And that'll cut it down like half. So only 30 options now. I also want to look for normally stocking only, because some of these are you're not available. I don't mind if it's marketplace. That's okay. One thing I'll note is a few of these are step down. They're not boost converters. Like this one. This is a regulator, and this is a regulator, and they're step down converters, not step up converters. So we do want to note that you want to make sure you pick both SEPIC style and step up. SEPIC is a single-ended something converter. Basically, it's usually a buck boost. Sometimes you can configure, by adding more Schottky diodes and more inductors, you can kind of reconfigure it so it's okay if the voltage goes a little bit under or above. That's okay. We'll just select both. The voltage supply max is fine. The voltage supply min, all these are fine. They all cover 3 to 5 volts. That's fine. And the voltage outputs for these are also fine because I just want at least 20 volts. The current output per channel, again, this is confusing because there's output and switch. Usually they're spec'd by the switch, I will say. So that said, if you look at the switch current, you're not going to get, there is one that's 2.8 amps, and it's like, wow, that's cool. But it's out of stock. It's the LM3410. Currently not in stock, so that's a little sad. Maybe I'll actually say I only want to look at in-stock ones as well. Okay, so back here. So the current output channel, so, basically there's 550 milliamps. That's kind of the max. So if that current output is important to me, the LM2704F, it's a little bit more expensive. It's $1.25 on tape and reel, but it does do the job. It's adjustable up to 20 volts. Built-in switch is half as much, 550 milliamps. Great for LCD bias supplies. What a coincidence. And then, this is basically your classic circuit, which is the same circuit you'd use for the fan 5331. And I did check the pinout. The pinout is identical. I can quickly look it up to verify for you. So it's switch, ground, feedback, shutdown, be in. And this is switch, ground, feedback, shutdown, be in. So 1, 2, 3, 4, 5. It's in the same order, and the same circuit. Although the feedback resistors may have to be adjusted, but that's not a big deal. But otherwise, this looks very similar. You have to give it the Schottky diode and the inductor, and does the rest. So this one's good. However, for a lot of the bias circuits, I don't need necessarily 550 milliamps. I'm glad it's available. And then, of course, if I'm willing to spend even more, there is a version that has a built-in 2.8 amp switch. So that's good to know. And it's actually kind of nice. It's also 1.6 megahertz. Again, it's more expensive. The original fan 5331 was about 75 cents. This is $1.50. But there is something available, the LM3410. So that's good to know. But for my purposes, I'm actually kind of okay with using 350 milliamp switch. So again, I only need like 10, maybe 20 milliamps at 9 to 12 volts. It's not a huge, again, it's not a power converter. It's a bias generator. So I'm actually okay with this one, the LM 2703, right? Because again, this comes in a family, the 2304, 2704, and then the 2705. All you pay more for the bigger switches, but this one does the job. And hey, it's in stock, hard to beat. But this will do the job quite well. Again, 2.2 to 7 volts in, up to 21 volts output. Simple boost converter, it'll do the job, and then pin compatible, so I can just drop it in. And for almost all of my OLED biasing needs, this chip will work quite well.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okie dokie, here's a question. When you have 2 or more IR LEDs, is there a possibility of timing issues with one being ever so faster than the other?
No, LEDs are essentially instantaneous.
Okay. Let me check the other spot. Do we have a graphic for a dying chip end of life? No.
Your little halo on top of it.
Yeah.
It goes to heaven,
Yeah.
there's a place. They all frolic.
Yeah.
On the circuit board in the
I don't know
sky.
I don't know if I'm ready to
It's a little morbid.
do that one yet. We'll see.
Yeah.
Ask me next week. Okay. That's Desk of Ladyada. We'll be
All
doing
right.
all of our regular shows throughout the week. Thank you so much, everybody, for joining us this Sunday night.
Thank you, everybody. Lots of live shows this week. Take care. Stay dry.